Okay, so we're going to go ahead and review all this information that we learned during the semester for trigonometry. Now this says part 1. There isn't really a part 1 and part 2, so this whole thing is put together. So just to begin with, you want to remind yourself of the unit circle, how you can look at a unit circle and determine the trig functions, and you want to remember the basic things. X is the cosine, y is the sine, and all the other things just go along with the normal definition. So if you're doing a cosecant, that's the reciprocal of the y value. So the way I would look at this is I would find the 11 pi over 6. We know the sine is negative 1/2. So this would just be the reciprocal. So that would be negative 2. All right. Okay, the tangent, recall, is y over x. So if you locate 120 degrees and locate y over x, what you would end up having is root 3 over 2 divided by negative 1/2. And the 2's cancel out, but what you're doing is dividing by a fraction, so you're really multiplying by the reciprocal. So you would end up with negative square root of 3. And the last one, the secant. The secant is the reciprocal of the cosine. The cosine's an x value, so this is really 180 over 3. This is really negative 60. Okay, so if you have negative 60 degrees, you're going to go clockwise. The cosine is 1 over 2, so therefore the reciprocal of that would be 2 over 1. So that value would end up being 2 then. Okay. Next, we want to look at just angles. One of the first things we learned in the semester is how to sketch angles. So we know that negative is clockwise, and we know that if we go clockwise, one lap would be 360. So generally what you want to do on this, remember, is you want to sketch out, just highlight your x-axis. Then you want to show your arrow. So this is going one full lap. And then what you would find on this is that if you did 360 minus 400, you would have negative 40 degrees left over. So what happens is negative 400 degrees is one lap clockwise plus an additional 40 degrees. Okay, so what you want to do is just kind of estimate the 40 degrees, and that would be your terminal side. Okay, and just estimate, this angle's not drawn to scale very well, but that would be a negative 40 degree reference angle. Okay, all right, and the next thing we want to look at is what is the smallest positive coterminal angle to negative 740. Well, what you're doing on this is you're just adding 360. There's a couple of ways I showed you how to do this. So if I was to just take a calculator, and like magic, my calculator shows up. So we're going to do negative 740 plus 360. This will still be a negative angle. So that's going to give negative 380. And you're trying to find the smallest positive coterminal angle. So then what you want to do is just take negative 380 degrees, add 360 to it again, and if you do that, it looks like you would still have a negative angle. So we do that, so that's negative 20 degrees. And then finally what you could do is just add 360 to it one last time, and then that would give you a positive angle that's coterminal of this. So remember, coterminal angles are always just off by 360 degrees, just multiple rotations around the circle. Okay, so that would be what that angle is then. Let's see, I was going to show you one other way we learned how to do this now. You could do the negative 740, and you could divide that by 360. And what that's going to do is it's going to give you negative 2.05 repeating 5s. Well, that just means 2 laps clockwise and then this additional angle left over. So if I added 2 to this just to get this decimal part, now if I take that decimal part times times 360, that would give you your 20 degrees left over like that. So you can also look at it that way and do it that way. That's beneficial to do it that way if you have a pretty big angle then. Okay? All right. So let's move to this next thing then. So now we're going to look at, remember how we take radians to degrees and so forth. So remember when you take radians to degrees, or I'm sorry, I'm saying that backwards, degrees to radians, you multiply by pi over 180. Okay, so we just multiply by pi over 180, that would give 540 pi over 180, and then you can reduce that fraction. And you could use a calculator on this too. 400, this is 3, but just to verify that, okay, we've got 3, so this would be 3 pi radians. And generally we're going to leave the pi in the answer. Okay. Okay, the next thing I wanted to just remind you of is how do you take radians to degrees? Well, the easiest way, there's 2 ways to do this. Pi is 180 degrees. So we just do 7 times 180 over 8. And again, we could do this on the calculator. So I'll do that. 7 times 180 and divide by 8. So that would be 157.5 degrees like that. Okay, so that's one way to do that. That's the way I generally do that. The other way to do that is you can multiply by the opposite, or the reciprocal of pi over 180, just multiply by 180 over pi. That wipes out the pi's, then you would just have 7 times 180 over 8, and of course you would still get the same answer. Okay? Alright, so that's page 1. I did want to remind you all of one other thing, though, on this, and like if you look at these problems right here, all these things are checkable on the calculator. Even though you definitely want to know how to use your unit circle and everything for future math classes and everything. So like on this first problem, if I put myself in radian mode, the way you do a cosecant is 1 over the sine. So I could put in 11 pi over 6, like that, and that would give -2. So that verifies that. This part C, if I did the secant, a secant's 1 over cosine, so if I do 1 over cosine of -pi over 3, then that should give +2. So it's all verifiable. And then the last one, you would have to go into degree mode, like this, and then you would go tangent of 120 degrees. And put that in, that will give you decimal, but that's the same as the square root of 3. So if you just put in negative square root of 3, our answer, then that'll match up. Okay, so I just did want to remind you that too, that you have the ability to check your answers. Okay. Okay, so moving to the next page, I want to do some reminders of what a reference angle is. So first of all, on this one, you want to figure out what quadrant this is in. So you could use your calculator to just change it to degrees. So if we go 11 times 180 and then divide by 6, that just verifies that this is a 330 degree angle. Okay, and then what you're doing with a reference angle, you do want to put this in radians, though, like this, though. So if you were to go through and graph this, a 330 degree angle, there goes my alarm. It's time to wake up. Okay, so what I was saying on this is your angle is in quadrant 4, but remember a reference angle is always drawn to the x-axis. So you would be doing 360 minus 330 degrees, so you would get a 30 degree reference angle left over. Now you could go ahead and convert that to radians. There's 2 ways to do this. You just multiply by 30 pi over 180. That'll give pi over 6. So in radians, that answer would be pi over 6. The other way you could do this problem is, well, instead of 360 minus 330, well, 360 is 2 pi, so you could do 2 pi minus 11 pi over 6. You could get a common denominator, which is 6. So if I multiply that by 6 over 6, then I end up getting 12 pi over 6 minus 11 pi over 6. So that gives pi over 6. So you can just keep it in radians if you want to, like that. But you want to remind yourself of what reference angles are and how to compute those, depending on the quadrant. The key thing to remember is a reference angle is always between the x-axis and the terminating ray of the angle. Okay? So let's see. The next one is just kind of a thing that we learned about basic definitions. So in problems like this, you want to make sure you know all of your definitions. The sine is y over r. The cotangent's x over y. The cosecant is r over y. The tangent is y over x. And the secant is r over x. So in this particular problem, you're given one trig function and enough information to figure out what quadrant you're in. Okay, so what we're going to do is figure out x, y, and r on these problems. Basically, you're also given the cotangent of this angle theta is positive. One thing that we went over to figure out what quadrant you're in, the cosine is negative, and the cosine's negative in two places. The cosine's negative in quadrants 2 and 3. The cotangent is positive here and there in 1 and 3, like that. So you would end up being in quadrant 3. Okay, so you got to figure out, kind of remind yourself of where is everything positive and negative of the trig functions. Okay, there's a number of ways we learned how to do that. Okay, so what we get then is the cosine is x over r. So that means in this problem, what we would have is we would have x is negative 2. That's negative. We're in quadrant 3, so x is negative. We would find y, and y would also be negative because we're in quadrant 3, and then r is 3. Okay, and what we know how to do here is Pythagorean Theorem, so we would have x squared plus y squared equals r squared. So that would be 4 plus y squared is equal to 9. That would be y squared equals 9 minus 4, so y squared is equal to 5. We do the square root of both sides, and you get plus minus root 5, but remember we're in quadrant 3, so that would be negative square root of 5. Now what you're ready to do is get everything put together then. So if the sine is y over r, then we're just going to have negative square root of 5 over 3 for the answer there. If the cotangent is x over y, then we would have negative 2 over negative root 5. That would become a positive answer, so that's 2 over root 5. And then you can rationalize the denominator by multiplying by root 5. So what you would have is positive 2 root 5 over 5 as the rationalized answer to that problem now. Okay. Okay, so I'm going to write that a little clearer. Positive 2 root 5 over 5. Okay. Then you move on to the cosecant. The cosecant's r over y, so r is 3, y is negative root 5. If I rationalize the denominator by multiplying by root 5 over 5, I would get a negative answer. The cosecant's negative in quadrant 3, so I would have, looks like negative 3 root 5 over 5. Okay, and then the tangent's y over x. Y is just negative root 5. X is negative 2. So this would be negative root 5 over negative 2. So that would be positive root 5 over 2. Okay, so that would be the solution there. And finally, the secants are over x. This r is 3, x is negative 2, so that would just be negative 3/2. And then notice I gave you the cosine was negative 2 over 3, so the secant's just a reciprocal of the cosine anyway. So that type of a problem is testing, do you know your x, y, r definitions of the 6 trig functions, Pythagorean theorem, rationalizing denominators, and can you determine what quadrant you're in? So there's a lot of little things going on in that. That's something we learned towards the beginning of the semester. Okay, we want to look at, kind of review some basic identities, and I picked out some of the basic ones. I want to review the sum difference and the half angle identities with you. Okay, so this one you're told to use a sum difference identity. So the first thing that you want to do is figure out how to either add or subtract two angles to get negative 15. And there's more than one way to do this, but the key thing is I'm going to just write this as 30 degrees minus 45 degrees. Okay? And then you want to remember your identity, and then you would have to look at your unit circle then as you're going through and completing the problem. So the cosine identity goes like this. You do the cosine times the cosine, different sine, sine, sine. So I taught you how to go cosine, cosine, sine, sine, different sine. So what we're doing is we're doing the cosine of 30 degrees multiplied by the cosine of 45 degrees, not negative, just 45 degrees, different sine. So now you add the sine of 30 degrees, and then you add the sine of 45 degrees, okay, like that. The rest of this, of course, you would just look up on the unit circle. So 30 degrees, cosine is root 3 over 2. Cosine of 45 is root 2 over 2. So we would end up having square root of 3 over 2 multiplied by square root of 2 over 2. And then plus, of course, we've got to do the sine. The sine is the y value. So there's the values of the sines. So we would have the sine of 30 would be 1/2. And the sine of 45 would be square root of 2 over 2. Okay, when you simplify this, multiply your fractions straight across, you'd have square root of 6 over 4 plus square root of 2 over 4. So a good way to write that answer is just square root of 6 plus square root of 2 and all over 4. Okay, and that would be it. Okay, now let's review a half angle identity. And so for the half angle identity, the first thing that you want to do on this is you want to just double this angle. Okay, and if you double that angle, then we're going to be able to use the half angle identity. So if we do 165 times 2 to double that angle, we'll get 330, and you should end up with something that falls on the unit circle. So what we're going to do is we're going to write the sine of 165 degrees as the sine of 330 degrees over 2. Now, the identity goes like this. It's plus minus the square root of 1 minus the cosine of 330, not the 165, then divide by 2. So that's the identity. Well, the thing that you want to realize on this is a quadrant 2 angle, and the sine of a quadrant 2 angle is positive, so therefore we're going to use the positive answer there, say. Okay? Then what we do is just work with the unit circle, and then we finish it up. So what we'll have is the cosine of 330 would be the x value. So it looks like what we're going to have then is positive 1 minus the square root of 3 over 2 all over 2. And then we want to simplify this. You have a complex fraction, so go underneath the radical, multiply by 2 to clear that fraction. So you would end up having square root, and then 2 times 1 is 2. You're doing a distributive property. 2 times root 3 over 2 crosses out the 2's, giving you square root of 3, then we'd have square root of 4. And then you can split it up like this, so that you're doing the square root of the top and the bottom separately, and then this would be a good answer to the problem. Okay, so you can write it that way, or you can write it as 1/2 square root of 2 plus square root of 3. It doesn't really matter which way you write that. Both of those answers are correct. Now, one thing I did want to mention on this is these problems are easy to check on a calculator. So I'm going to put myself in degree mode. Let me just show you how easy it is to check these things. So if you were doing the first one, if you're doing the cosine of -15, you'll get this decimal answer. Our answer was this. Now you'd have to put this in like this, parentheses, square root of 6, and then plus square root of 2, and then divide by 4, like that, and that matches up, so it's easy to verify that's right. The next problem, same way. You could go sine of 165, get that answer, and then take our answer. Now our answer, I'm going to go down the bottom here and just put it in like this. It's square root of 2 plus square root of 3. You have to put that in like that, and then divide by 2. Okay, and see if they match up. Oh, what in the world did I do? See, I may have made a mistake on that. We did sine of 165. So let me go through. Oh, you know what I did? And this is, I guess, the benefit of checking your answers. I did something kind of dumb. This minus, I just kind of changed that to a plus. Not paying the slightest bit of attention there. Okay. So anyway, let's try now. All right. I could lie and said I did that on purpose to see if you were paying attention. But I wasn't. I just kind of slipped that one up. So let's do that one more time on that. So that should check out now. So if I go, and let me move this over here. And if I do this now, so if I go sine 165, get that? Okay, now our answer was square root of 2 minus square root of 3. Close parentheses, divide by 2, and that's the same. Okay, now we got it. Okay, so you can do that. You can check and verify. You can catch little mistakes like that pretty easily on these problems then. Okay, so that will wrap that up. And then we'll move on to the next page here and kind of continue some work with some trig identities then. Okay, so let's see. Well, now we're into vectors, okay? So I kind of got things in kind of different orders here. So this is kind of everything that you want to know about vectors, all in this one problem. Okay, so let's review all these different things about vectors. The first thing that you want to know how to do is plot the vectors and do that. So let's go ahead and do this. Now this one right here, you're just going over 4 up 3. I is kind of like x, the j is like y. So it's not much different than just plotting the point 4, 3. So if I go over 4 up 3, that's where the vector would terminate. Now you do have to draw this correctly, and you just put a single arrow. You start from 0, 0, and then there's your vector like that. Okay, so I'll just label that as the vector u. Okay. The second vector would be, you could think of like plotting the point -2, 4. So on here we would just go 1, 2 to the left, up 4. That's where the vector would terminate. And then sketch in the single arrow, again from the origin. And that would be how you do vector v. Okay, so that's your vector v. So you definitely want to know how to plot vectors. That's a real simple thing to do. And then you want to be able to do arithmetic with vectors. So this one you're doing 2u minus v. So if you do 2u minus v, it's just algebra. So you're really going multiplying the first vector by 2. That's called scalar multiplication. and then we're going to subtract the second vector, negative 2i plus 4j, like that. Okay, it's just like algebra, so this would be 8i plus 6j plus 2i minus 4j, and then this would be 6i plus 2j. All right, so that would be the answer to that. That's just algebra of vectors. Okay, so that would give you that. So you want to know how to do that. The other couple of things you want to know how to do are to find the magnitude of a vector. So when you do the magnitude of a vector, we're doing the magnitude of this vector right here. We generally represent this magnitude with the double arrows, like this. And what we do is we just do the square root of the I component squared plus the j component squared. Okay, so the general formula is the magnitude of a vector v is just the square root of a squared plus b squared. Okay, and that would be if your vector is in the form ai plus b times j. Okay, so that's the formula. So we would end up having the square root of 36 plus 4. That's the square root of 40. And then you do want to simplify this by splitting this up like this. So you would have the magnitude would be 2 times the square root of 10. Okay, and what you're doing there with that 40 is you're looking for a number that's a factor of 40 that has a square root. And typically to do that, you just want to know what your perfect squares are, like 4, 9, 25, 16, so forth. Okay, perfect squares. Okay, right? When we do the unit vector, and a unit vector just means the magnitude is 1, the formula for a unit vector is you do the magnitude of your vector v. Whoops, that's not right. That's not right. I'm doing that backwards. You do vector v divided by its magnitude. So that's the formula for a unit vector. So your unit vector that I'm going to call u, we would just take this vector and we would divide by the magnitude that we just found, see? Okay, now you would want to split this up and write this like this. 2 over 2 root 10 u. Hold on, teacher. You're not doing this right. Okay, you need to take this form, 6i plus 2j. Okay, 6i plus 2j, that's the result of that vector. Okay, and then you want to divide that by 2 root 10 like that. Okay, so we would have 6 over 2 root 10i plus 2 over 2 root 10j, like this. And simplify it out, so it looks like this is 6 over 2. And you do want to simplify and reduce fractions. That's 3. That's 1. And then you probably want to rationalize denominator, so we would have 3 over root 10i plus 1 over root 10j. And it's okay like that if you wrote it that way, unless I said specifically to rationalize denominators. If you rationalize denominators, you would have 3 root 10 over 10i plus root 10 over 10 times j. Okay, so that would be the value of your unit vector. Okay, all right, so you just take the vector and divide it by its magnitude. So you want to know how to do those two things. There's nothing to it. If you know the formula, the methodology doing that, there's really nothing to it. Okay, the next thing we want to do is the angle between two vectors. And the formula for this is we say the cosine of the angle theta between the two vectors is the dot product divided by the product of the magnitudes of these two vectors. Okay, so we're just going to have to work this out. When you do a dot product, what you're doing is you're multiplying the I components. So you're doing 4 times negative 2, and then plus, and then you're multiplying the j components, which would be 3 times 4. That gives your dot product. Okay, and then the magnitudes, you do this. To do the magnitude of the verse vector, when you're doing that, you do the square root of a squared plus b squared. So that's how you find the magnitude of vector u. You do the magnitude of vector v the same way. That would be negative 2 squared plus 4 squared. Okay, so we do that. Now you got to get all this worked out. So this is going to be, looks like negative 8 plus 12. And then this is going to be the square root of 16 plus 9. That's square root of 25. And then this is going to be 16 plus 4. So that's square root of 20. Now you're going to do this on the calculator. So that's 4 over, and this is 5 times the square root of 20. Now you could split this up if you wanted to. So we could break up this 20 into the square root of 4 times the square root of 5. So that would be 4 over, and then this would be 5 times 2 would be 10 over root 5. Okay, you could reduce that fraction to 4 tenths is 2 fifths, so you would end up having this. Okay, so that's what you do. Now, what you'd want to do here is theta, since we have cosine theta is equal to 2 over 5 root 5, then we just do theta is the inverse cosine of 2 over 5 root 5. And you just want to make sure that you put that in your calculator right. There's one little feature of this that students are kind of bad to mess up on too. And so you want to make sure that you're in degree mode. And then you would go inverse cosine of 2. Now watch how I do this. See, you got to put the denominator in its own set of parentheses. If you don't do that, it's not going to do this right. Okay, because that's got 2 different terms on it like that. So that needs to go like that. That must be put in like that then. Okay, then when you do that, you would get about 79. We'll just round that to 1 decimal. That's about 79.7 degrees. Okay, so that's real important that you're careful about how you do that. You could also go all the way back here if you wanted to. I mean, you could go like this if you, without simplifying all this, because you're going to have to use your calculator anyway. You would just go 4 divided by 5. Whoopsie, and I got to put parentheses around that, and then I'd do 5 times square root of 20. Like that, and it gives the same answer. Okay, so you can do that like that. It's, you basically just got to do the formula, and then you're going to be working with that one on your calculator then. Okay, now let's see. The next one we already really did. Now this is supposed to be a dot. That's if you have u cross v, we call that a cross product. We didn't go over how to do a cross product in this class. So basically what we're doing is u dot v again. We just do the I components and multiply, so we do 4 times negative 2. Then we add the product of the j components, and that would be negative 8 plus 12, so that would be equal to 4. Okay, so these are the different vector computations we learned how to do. And that's mainly what I want you to know for your final. Okay? All right, so next thing we're going to do a quick review of is the graphing, and what I want you to study on the graphing is the sine and cosine. I mean, we learned how to do the graphs of all 6 trig functions. The sine and cosine is the main thing that I want you to go over and review for your final. So the form goes like this. You've got a we're in a cosine or a sine, so we have a cosine b x minus c plus d. And you want to remember all these things, that a is the amplitude, that the period on a sine or cosine is 2 pi over b, with b being a positive number. C is the phase shift. And then finally the d is a vertical translation. You're either going up or down. Okay? So if we were to go through and do this, we're going to do a graph on this one. The first thing is this is not in a factored form, so that 3 needs to be factored out. So you want to make sure you remember how to do that. So we have negative 2 cosine of 3 times, whoops, Okay, and we're going to take the 3 out, and then we have x there, and then what goes there is you're always just taking that number divided by this number. So what goes there is pi over 3, like that, and then plus 1. Okay, so we've got that in the standard form. Just be sure when you factor out the number in front of x, all you end up doing is just taking this number divided by that to get pi over 3. Okay, now we can get everything figured out. So the amplitude comes from that number. But remember, an amplitude's a positive number because it's a distance, so the amplitude's going to be 2. Okay, the period is 2 pi over absolute value of b, with b being 3. So that would be 2 pi over 3. Okay, so that gives the period then. Okay, remember the increment is always just the period over 4, or a fourth of the period. So I'm going to just do 1/4 times 2 pi over 3. Okay, so what you would have there is that would be 2 pi over 12, which would reduce to pi over 6. So you're going to increment this x-axis by pi over 6. Okay, and then your phase shift is this number, the pi over 3, and since it's a plus, that means you're going to the left, so that would be a pi over 3 to the left. Okay, so after you've kind of got everything figured out, then we're ready to go through and get the graph put together. So generally what we're going to do, if you have a phase shift, generally the easiest way to do the graph is to start at the phase shift. So what I'm going to do is I'm going to count out by these values. So if the increment's pi over 6, we're going to go 0, pi over 6, and we're counting by the numerator, 2 pi over 6, 3 pi over 6, 4 pi over 6, and so forth. And that gives you 5 key points right there. Now you want to reduce these fractions, of course. So you want to label all this. So we've got pi over 6, 2 pi over 6 is pi over 3, then 3 pi over 6 is pi over 2, and then 4 pi over 6 is 2 pi over 3. And see, that matches the period. Okay, so if you count to 5 from 0, you should end up at the period. And then I'm going to go backwards with these things too, although I'm only going to graph this through one period, but I am going to start at the phase shift because that's the simplest way to learn how to do a graph when you have a phase shift on a sine and cosine, is to start there. Okay, so that should give us everything we need there. Okay, and looks like we have an amplitude of 2. We have an up 1 transformation, so it makes a lot of sense to go up 3 or 4. So I'm just going to have you go up 3 or up 4 maybe, and then down -3 or 4 if we need to, like that. Okay, so the way that we learned how to do this basically was you want to start, you can do this in one step actually, or you can do it in 2 steps. I'm going to do this in 2 steps. So the first thing I'm going to do is I'm going to graph out just the inside part of this. Okay, I'm just going to graph out y equals cosine of 3x plus pi over 3. This is just the way I taught you how to do this. You can do these in 2 steps pretty easily. So you start at the phase shift. The phase shift is pi over 3 to the left, so we would start here. Okay, now remember a cosine starts at the point 0, 1, so that first point is going to start there. Then you can cycle through the points. Okay, so you can go now, it hits the x-axis, hits the low point of -1, back to the x-axis, and like that. So that would be one cycle. You got 5 key points on that. Now that's not the answer of the problem. That is just what that part is. And then what you want to do to get your final result, the final result, we're doing y equals -2 cosine 3x plus pi over 3 plus 1. Okay, well what you're doing on this is you're taking each y value and doing these 2 things to it. So you're multiplying by -2, and then you're adding 1. Okay, so I'm just going to do each of these calculations right here. So this has a y value of 1. So you would do negative 2 times 1 plus 1. That's negative 2 plus 1, so that's negative 1. So that point now moves there. So that's your first point. This next point has a y value of 0. So you do negative 2 times 0 plus 1. That's 1. So that point moves there. And then you got the next point has a y value of negative 1, so it's negative 2 times negative 1 plus 1. That's 2 plus 1, so that's 3. Okay, and then the rest of it's predictable, so you're going to have a graph going like this. The next point's going to be here, and then the next point's going to be down there. We've already done those calculations, so that would be your graph like that then. Okay? Now again, you want to do these things by hand, but you also in a trig class you want to exit a trig class by knowing how to graph things on your calculator. So with this kind of a thing, we've got Radian Mode. I'm going to put myself in Radian Mode, and then I'm just going to put in the graph. You can put in both graphs if you want to. You don't have to though. I'm just going to put in the final graph. So we have negative 2 cosine. 3 parentheses, and you could put it in the original form. I would even recommend that you put in the original form just in case you made a mistake when you factored, so I would even recommend that. So negative 2 cosine 3x plus pi, close parentheses plus 1. So that's what we're doing. And then you can set up your window. Really all you got to do is negative pi over 3 to pi over 3. Okay, so for the window, let's just go negative pi over 3 to pi over 3. Okay, you can scale by our increment. Our increment was pi over 6. So you put that in. And then we can go like negative 3 to 3 on the y's. Like this. Okay, so that would be a good viewing window. Then if you graph it, you want to just make sure everything matches up, and it does. So you've got all these points matching exactly the way they're supposed to. So that would verify that you have a correct answer on that then. Okay, so then the domain, remember the domain is what is x. Well, x can be anything. A cosine wave goes on forever, infinitely. And we're not talking about negative pi over 3 to pi over 3 because that's just one period. So the domain is all real numbers, and it's always going to be that on a sine or cosine wave. The range in this problem is going to be the low value of y. So you just think of this as the low y times the high y. And the low y is negative 1. The highest value of y is 3. Okay? So you got that. So that's a good example of a graph. So like I said, you want to make sure that you know how to do sine, cosine. Those are the things that you use the most often. And then probably the tangent probably comes in third, but I want to make sure you know the sine and cosine. That's the main thing. And after doing the swinging ball project, that probably gave you a really good review of graphs of sines and cosines anyway. Okay, now we'll move to the next thing here, and what I want to do here, I want to go ahead and move to proving an identity. So you do want to go over establishing an identity. Generally on a final exam, you're going to see probably one proof of an identity. So again, the thing that you want to do is the structure is real important to me. You want to make sure that you don't write, messy and stuff like that. So you want to start this way. The thing that I always said to do was to write down what you think is the most complicated side, which is, to me is clearly this side's got more stuff on it. So you want to write that side out, and then the other thing is you write an equal sign. Now don't start these problems any other way. Just write down the side and the equal sign. I have a hard time sometimes getting students to do this in a certain way. Students tend to write all over their paper, and I can't make heads or tails of what they're doing. So what you do now is you're going to go straight down your paper, and those equal signs are just going to keep popping up. Eventually, the right side should pop up if you do the problem correctly. So you just kind of think about what you would do. Now I would do a distributive property, so I'm going to distribute the sine through this. So I will write out that I have sine x tangent x cosine x minus sine x cotangent x cosine x. So I've got sine x here. The tangent is sine x over cosine x, so I'm using an identity. I'm going to leave the cosine the way it is because that will divide out. And then I'm going to bring down the sine x. The cotangent is cosine x over sine x, and then times cosine x. Okay, so just using basic fundamental identities. And then you can do just a little algebra. That'll cross that out. That'll cross the signs out. Write what you're left with. So what you're left with now is it looks like you're left with sine squared x minus cosine squared x, like that. Okay, now what you can do there, you're trying to turn this into 1 minus 2 cosine squared x. So we know a sine, remember, and you don't have to write this as a part of your proof. You could kind of do this on scratch paper if you want to. So you could solve for sine, and you would just get sine squared x is 1 minus cosine squared x. So I'm going to change the sine squared x to 1 minus cosine squared x. Then I bring down the cosine squared x that's already there, and whoops, I put the wrong sign in there. So that goes like that. And then you would have 1 minus 2 cosine squared x, and then that would prove that. So see, that's a nice, well-structured proof, and that's the way your proof needs to look. It's just straight down the paper, equal signs, stuff like that. And by the way, if you do stuff like, if you wrote this first step as sin tan cos minus sin cot cos, you're going to lose points on that because you can't lose that variable x. It's got to be there. Okay, I see students do that kind of thing all the time. Drives me crazy. Okay, keep it in there. I always say a sign without an x is a sin. It's a deadly sin. Okay, so you got to have that sign of x. All right. Okay. All right. Now let's review some trig equations. Okay. Now again, I've picked out kind of the main overall type that we learned how to do. So a lot of these things, you know, follow the unit circle, or by design. They don't have to. If they don't follow the unit circle, then you have to use a calculator to do that. So if you're looking at this first problem right here, the first thing you want to do is isolate the cosine. So step one is just add square root of 2 to both sides, then divide by 2. So you would end up getting the cosine of x is equal to the square root of 2 over 2. Okay, now what you're doing is you're finding all real number answers. If I say find all answers, then that means you're going to need to have a formula. Okay, so you're not going to just get a specific answer on a certain interval. So what you would do is, we know the cosine is the x value on a unit circle. So there's 2 places on a unit circle where the cosine takes on the value of positive root 2 over 2. So in radians, those are your 2 answers. So we just write the answer like this. Okay, we just say that x is equal to pi over 4, and then another lap around the circle is 2 pi, so we just say 2 pi k, and then the second answer is x equals 7 pi over 4, and again plus 2 pi k. You do have to tell me that k is an integer, so you can use that abbreviated z that I showed you for integer like that. And that would be it. Okay, you want to know how to get the formulaic answer to any of the trig functions. Okay, and again, the thing on this is the period on that. So you just have a basic cosine of x. It doesn't have a period change, so that's why it's 2 pi. Okay. All right, the next kind of thing we looked at was factoring. We learned how to solve trig equations on interval by factoring. This time you're given I want a radian answer, and I want it from 0 to 2 pi, but you include the 0 but don't include the 2 pi. So this is a factoring problem. So you have tangent squared x plus 2 tangent x plus 1 is equal to 0, so you'd want to draw your two parentheses out. So we would just have tangent x and tangent x, 1 and 1, like that. And then you would have the inner term is 1 tan x. The outer term is another 1 tangent x. We're wanting those to add up to 2 tangent x. So that just means we have two plus signs. Okay, so when you're factoring a trinomial, the first term is just the tan and tan. The last term is the 1 and 1. The 2 tangent is the outer and inner added up together. Okay, so you want to do that. So the next thing we'd do here is you set each factor equal to 0. Well, we would be solving the same equation twice, so there's no need to go through and do the same thing twice. Okay, well, you'd isolate, so you'd subtract 1, so you would get tangent of x equals -1. Okay, so now if we go through and look at the unit circle on this, we just need to find where is the tangent -1. Well, remember, a tangent's y over x. So you're really just trying to figure out where is y over x -1. Well, that happens two places, okay? The one place it happens is right here. Y over x is -1. The other place it happens is here at 7 pi over 4. So just think of it that way. So if you do root 2 over 2 divided by negative root 2 over 2, you get -1. And also if you do over here, negative root 2 over 2 divided by root 2 over 2, you also get -1. Okay, so those are your two answers on that, and we're just writing these answers. So usually in a set brace, we would just say our answers are 3 pi over 4 and 7 pi over 4. Okay, like that. Okay, so that's another thing you want to know how to do is solve a trig equation when you have to factor. So you want to be able to handle the different types of factoring problems. Okay, the other thing I wanted to remind you of is that these things can be checked. So this can easily be checked. Now you want to be in Radian mode when you do this. So what you do is just graph the function. And you got to put it in your calculator, right? So if you do tangent squared x, you go parentheses tangent of x, and then square it. So that's how you would put that in. And then plus 2 tangent x, and then plus 1. And what we're going to do is, since we're solving this on the interval 0 to 2 pi, for the window, you would want to do that. You would want to go 0 to 2 pi. The scale doesn't really make any difference. You can put anything you want to there. And the y's probably don't make any difference either. -5 to 5, you just want to go below and above the x-axis like that. So let's do a window like that. And then when I graph this, the way that we want to check the answer on this, so we're looking for where this is equal to 0, like this. So I do want to make sure that I've got everything in here correct. Okay, so I've got that. And then you can just trace your answer. So the first answer is 3 pi over 4, and then we'll see if 0 pops up. And it does, so that verifies that answer. Okay, and then the second answer is 7 pi over 4, so if I trace at 7 pi over 4, that'll verify that answer. Okay, see, that's giving the y value like that then. Okay, so that's how you can check and verify everything and until you're right. You can do that on any trig function that you want to, basically. So that kind of is a real nice thing to do. I want you all to exit the class with good competency with and without calculators. We're in a technological world, and I think being able to use technology to verify things that you do is really, really important. Okay. All right, so that would wrap up and verify that that answer is right. You can do that anytime you're doing any trig equation, really. Okay, so those are a couple of examples of trig equations. Next thing I want to get into a little bit here is law of sines, law of cosines, area of triangle, that kind of thing. So the next problem we have is you're finding an area of a triangle and you're given all three sides. So if you're given three sides like you are here, then Hurons formula is what you want to use. Okay, so Hurons formula, there's two parts of it. You find the semi-perimeter. The semi-perimeter just means add up these sides and then divide by 2. Okay, and you can do that just on your calculator in one step if you want to then. Okay, so I'm going to do that. And so I'm going to do 3.2 plus 3.6 plus 4.2, and then divide that by 2. So that will give a semi-perimeter of 5.5. Okay, and then the second thing that you do is you use Hurons formula. So Hurons formula goes like this. What you do is you do the semi-perimeter, and then you do the semi-perimeter, then you subtract each side. So S minus A, I'll use little a to represent a side. And then S minus B, the second side, and then S minus C, the third side. And then you do the square root of that. So you just put this in, and you'll do this on the calculator. So to get this set up, the semi-perimeter is 5.5. Then you'd do 5.5 minus a side, 5.5 minus another side, and then finally 5.5 minus 4.2. Okay, then you can put that in your calculator in one step if you want to, and that's what I'd do, is just do it, let the calculator take over. So put in the square root symbol, not the 10 symbol. So square root like that, and just put it in exactly like this, 5.5, parentheses, 5.5 minus 3.2, close parentheses, then it would be 5.5 minus 3.6, and then finally 5.5 minus 4.2. Okay, so just get everything put in, press enter, and that will give you an approximation. So that's about, we'll just round that off to 1 decimal, so that'd be about 5.6. This is an area, so you'd want to write your units. That's square units. So do take off if you don't do units, because it's important. Units are very important. Okay, so that's Hurons formula. That's basically how you would put that in then. Okay? Okay, all right. Moving to the next thing is, let's see what we got here. Probably just a right triangle trig problem. You know, SOHCAHTOA type of stuff. So let's see, this one says the radio transmission tower is 100 feet tall, and it says how long should a guy wire be if it's attached 5 feet from the top. So I kind of look at this like this. That's 5 foot right there. And then the tower, it says, I guess it's implying that this tower, the whole entire tower, to the very tip of that is going to be 100 feet tall, like that. Okay, and then it says you're making a 42.5 degree angle with the bottom. Well, what you're finding is the guy wire, so the guy wire is X, and you're going to assume that this is a right triangle, so you would do that. Well, the first thing you'd want to do is this part right here would just be, you can figure that out in your head, that's 95 feet. So what you have then is you have a right triangle, and this right triangle you have X here, you have 42.5 degrees here, and then you have 95 feet there. That's enough information to figure out X. So if you talk this out, you've been given, in relationship to this angle, that's a side opposite. That's the hypotenuse. So the sine is opposite over hypotenuse. So you would have sine 42.5 degrees is equal to 95 over x. You would solve this equation. You can cross multiply. So you would have x times sine of 42.5 degrees equals 95. Divide by the sine, you would get x equals 95 over the sine of 42.5 degrees. And then you can go straight to your calculator, and again, be sure that you're always checking the mode on the calculator. See, I'm in radians right now. You got to be really careful about that. If you're not paying attention, you can end up getting answers that wouldn't make any sense. So what I'll do on this then is I just do 95 divided by the sine of 42.5, and that will give me about 140.6 feet. Should be the answer to the length of that guy wire. So that's something that you definitely want to review. Is just review your SOHCAHTOA, your right triangle trig definitions, and be prepared for maybe a right triangle type of problem. Okay, next thing we'll do is review law of sines. These are things that we've done pretty recently, also law of cosines. So you're solving a triangle here. And sometimes on an exam, I might not have you find all of the parts of the triangle. I might have you find one part or two parts or something like that. So anytime that you're given a side-side-side case, that tells you that you have to do the law of cosines. Okay, so you want to review your law of cosines formulas. Okay, so the first thing we'd have to do is you want to pick a side on this. Now you can draw the triangle if you need to. I usually am very visual, so I like to label things. So we're going to say that's alpha, beta, gamma. Okay, and it looks like side A is 8.5, side B is 9.8, and side C is 10.4. So it's up to you where you start. I'm going to start just with alpha. And remember, there's three forms of the law of cosines. So if all I got to do is use law of cosines one time, so I'm going to start this way. A squared is equal to B squared plus C squared minus 2BC cosine of alpha. And I taught you how to remember that in words. It's just you pick a side. The square of a side is the sum of the squares of the other two sides minus twice the product of the other two sides, and the cosine of the angle on the opposite side of A squared. So that alpha is matching the A. Now I'm going to find alpha, so I'm going to solve this equation for cosine of alpha. So I'm just going to isolate the cosine by itself. So I do A squared minus B squared minus C squared equals negative 2BC cosine alpha. Then I divide both sides by negative 2BC, so I get A squared minus B squared minus C squared over negative 2BC is equal to cosine of alpha. Okay, now I'm going to plug everything in. So A is 8.5, B is 9.8, C is 10.4, and of course going to use a calculator on this, then negative 2 times B times C, like that, and that's equal to the cosine of alpha. Okay, so it's time to get your calculator and just make sure you have everything done on here. Be careful, be sure that I just like to do this in two steps, so I'm going to do 8.5 squared minus 9.8 squared and minus 10.4 squared. Get that answer. Okay, and I like to just kind of write this down, negative 131.95, and then do the bottom, negative 2 times 9.8 and times 10.4, and that will give negative 203.84 equals cosine of alpha. Now over here, alpha is going to be the inverse cosine of these numbers. Now that you're going to get a positive, so I'm just going to write it like this. So no need to put the negatives in because it becomes positive anyway. So then in degree mode, you want to make sure again you're in degree mode. Okay, and then what you would do is just go inverse cosine of 131.95 divided by 203.84, and we'll round that off, I guess, to one decimal, so that would end up giving us that alpha is about 49.7 degrees. Okay, so that takes care of that answer. Now what we're going to do in step 2 is we need to find, one of the other angles. So now it turns out you can use law of sines. So in step 2, I move on into doing law of sine C. Okay, so when I do law of sines, and remember you use law of sines whenever you have an angle on the side opposite. So I'm going to match up this ratio like this. That has to be matched with this. Let's go ahead and find beta. Beta is matched up with 9.8. So we only have one unknown there. So in step 2, I move on and I just do the law of sines. Okay, so the proportion would go like this. We would say sine beta over the side opposite is equal to, and then on this I'm going to go the sine of 49.7, the angle I just found, divided by its opposite side, like that. Okay, then you can just multiply both sides by 9.8. You can do this in your head if you want to. So we would get sine of beta is equal to 9.8 sine 49.7 divided by 8.5. Okay, so I'll write down and get the decimals on this using my calculator. Okay, so if I do this, I'm just going to have 9.8 sine 49.7 and divide by 8.5. That'll give me a bunch of decimals. So 0.8793117213. And then beta is going to be the inverse sine. Okay, now what I do is remember the answer key stores the last computation. So the way I like to do this is just go inverse sine, use the A and S key, and then that gives the answer. Okay, so it looks like beta is going to be 61.6 degrees. Okay, so we end up getting this. And then, of course, one last step, and then we got it all put together then. Okay, and then the last step, step 3, would be just find the angle gamma. So gamma is going to be 180 minus 49.7 minus 61.6. Okay, I'll just punch that in on my calculator. So I've got 180 minus 49.7 minus 61.6, and that will give an answer on that of 68.7 degrees. Okay, so that would solve the triangle. The other thing that I wanted to remind you of here basically is this. You have the ability to check your answer on these problems, so it's kind of helpful to review how to do this. So I'm going to show you how to do this. We got alpha. I'm going to put beta in here, and then I've got gamma, 68.7. So actually, here's how easy it is to check your answer. What you do is you do law of sines. So what I like to do on this is just pick an angle. Let's start with alpha. So we'll do the sine of 49.7, and then we divide by its opposite side, 8.5, and just get the answer. Okay, so that gives that. Now do the same thing with another angle. Sine of beta, 61.6. Divide that by its opposite side, and you want to see if you get close to the same answer. And you do. And then finally do the sine of gamma, 68.7, divide by the opposite side. Okay, when you do that, you get about the same. Okay, so that's a simple way to go through and check and verify your answer, and it didn't take more than like 30 seconds to plug that in the calculator, so that checks the answer to that problem. Okay. Okay, so that'll wrap that up then. So those are a couple of, that's a law of cosines, law of sines problem. That's a good problem because it tests both law of sines and law of cosines together. Okay, so that's one of the reasons I like that. Okay, here's another area of triangle problem. So I'm going to go ahead and go through this. Okay, so this is, we talked about how to work with different types of regular polygons to find areas using the trig formulas that we've learned. So I just want to go over this a little bit. This right here, you're given all the angles in a pentagon is 180 degrees. And you can divide this up into 3 triangles. You can always take a regular polygon and divide it up into a series of triangles. Like that. Okay, so we got 3 triangles, and each side in this problem is given as 2 meters. So this is 2 meters, and so forth. So we have enough information and area of triangle formulas to fill this out. So the first thing I wanted to mention is this is a side angle side case. So if you have a side angle side case, we have an area of a triangle. So I'm going to call this triangle 1, triangle 2, triangle 3. So it turns out it's real easy to find the area of triangle 1 and 2. So the area of triangle 1 is just 1/2 the product of the 2 sides times the sine of the angle in between. That's the side angle side formula for finding an area of triangle that we found. Okay, so it's easy enough to do that. So the area of triangle 1, notice the 2's divide out, so we can now just do this computation then. So if we just do in degree mode, if we do 2 sine of 108, that'll give the area of that triangle. Okay, so that's about, we'll just say about 1.9 square meters is what that is then. Okay, all right, so that'll take care of that. And then that would give us the area of the other triangle too, because it's the same. So the second triangle is the same thing. Say it's side angle side. So the area of triangle 2 would also be about 1.9 square meters. Okay, like that. Okay, now we got to kind of see what we got on the next thing here, and see if we can make this determination on this. Now all we know is one side. We don't really know these angles or anything, so we have to go through and see if we can figure out what we need here. There's a couple of ways we could do this. We might be able to, if you want to use Hurons' formula, you would have to know the length of these 2 sides right here, because we already know this side's 2. And you're gonna, in order to figure out those sides, you're gonna have to figure out these angles a little bit. Okay, so I'll show you how to think through that. Okay. Okay, so my thought on this would be to figure out what this side right here is. Okay, and I'm going to call that x. And again, you have a side angle side, so law of cosines is what you want to use. Okay, so this goes like this. You would say x squared equals, and then again, it's the product of the squares of the other 2 sides, so that'd be 2 squared plus 2 squared, minus twice the product of the other 2 sides, and then times the cosine of the angle in between. Okay, so that's the law of cosines that will figure x out for us. Okay, then we'll be in business. Okay, so we've got 4 plus 4 minus 8, cosine of 108 degrees. Okay, so we just end up getting x squared equals 8 minus 8 cosine 108 degrees. Then we can do square root of both sides. Okay, so we'll get what x is by using law of cosines. Okay, so if I do this, and you can just put this in your calculator in one step if you want to, like this. If we go square root of 8 minus 8 cosine 108 degrees, then that will give the length of that side. Whoops, I did the wrong thing there. I must have put in an extra, oh, I have an extra parenthesis there. Okay, so I got that. All right, so it looks like that is going to work out to give you this side And then we're probably ready now to use Hurons' formula to get this final answer of this problem then. Okay, so we'll just round that off to about 3.2 meters like that. Okay, so we've got 3.2 meters here and we got 3.2 here now. These two triangles are equivalent. They have the same angle, so you have that. So notice now what you have is you have three sides. So now in step 3, you can move on into Hurons' formula. Okay, to get that. All right, so what we would do is the semi-perimeter would be add up the three sides and divide by 2. Okay, like that. Okay, so I'll go ahead and do that on the calculator. So 3.2 plus 3.2 plus 2, and then divide by 2. So that semi-perimeter would then be 4.2. Okay, the area of the triangle by Hurons' formula, you would do the semi-perimeter times the semi-perimeter minus each side. Okay, then you do the square root of the whole entire thing. Okay, so I'm just going to do that in one step on the calculator. Yeah, let's see what we get here. So I've got 4.2. And then parentheses 4.2 minus 3.2. Now I'm going to write this like this. Okay, since you're doing the same thing twice, you could square it. And then the next thing would be 4.2 minus 2. So you can put that in your calculator like that. And let's see what we get there. Okay, so that is about 3.03 would be what the area of that triangle is then. So we'll just say about 3. We'll just say 3. Okay, so that's about 3 square meters like that. So that if you look at this visually, the area of these three triangles, they look all about the same. Okay, so step 4 would just be find the area total. So the total area, you just add them all up. You've got, let's see, the areas were 1.9 meters squared and 3, like that. So I guess the triangle in the middle is the one that has the biggest area. So now you just do that and you've got your final answer. So I'm just going to do 1.9 times 2 plus 3, and that'll give 6.8. So the final answer on this problem would be 6.8 square meters. There's a lot of work to that problem. It's kind of a nice problem. I like these problems because there's a lot. I mean, if you look at this problem, it's a beautiful problem. You had to use the side angle side area of a triangle. You had to use Hurons' formula. You had to use law of cosines. It's all there. Great problem. Okay, next thing I want to review a little bit is inverse. Talk a little bit about inverse trig. Okay, there's my unit circle. Well, it looks more like a unit oval. There we go. That's a little better. Okay. All right, so let's just review a little bit about what we have with inverse trig functions. So first of all, you got to recall these ranges. If you have, and I'm going to write these over here because they're real important to review and remember something about. So the range of the inverse trig functions are for an inverse sine, that range is negative pi over 2 to pi over 2. So your answers to an inverse sine are going to fall within that range, and there's only one answer to these problems. If you have an inverse cosine, its range is 0 to pi, and if you have an inverse tangent, it's parentheses negative pi over 2 to pi over 2, because the inverse the tangent's undefined at pi over 2 and negative pi over 2. So what you're doing on this is you're just interpreting this on the unit circle. So the meaning of this problem would be cosine of some angle theta is 1/2. So you're just looking in reverse on the unit circle. Where on this range from 0 to pi is the cosine equal to half? The cosine's equal to half at pi over 3. Not here. You don't go down here because that's out of range. So the answer of this problem would just be pi over 3 only. There's only one answer of these problems. Okay. The next one, this is really saying the sine of theta equals negative square root of 3 over 2. So the sine is the y value. And again, the range is negative pi over 2, which is down here, to pi over 2. So you're only looking over here like this. Well, in this range here, the only place where the sine is negative root 3 over 2 is right there. Now, 5 pi over 3 is not the right answer of the problem because you have to give a negative angle on that. So that would be negative pi over 3. Okay, see, that's a negative 60-degree angle, which is what pi over 3 is, say. Okay, so you have to say negative pi over 3. You cannot say 5 pi over 3 because that's outside of range. That's a kind of a common misunderstanding that students make on these problems quite a bit. Okay, the next problem would really be saying if you have arctangent, that means the same thing as tangent theta is negative 1 over square root of 3. So you're really looking at where y over x gives this result. Okay, and again, on an inverse tangent, you're from negative pi over 2 to pi over 2. Okay, so you got to figure out where would y over x be that negative answer. Well, it's going to have to be down in this quadrant 4 because you're getting a negative answer. Well, that would happen here because notice you would have negative 1 over 2 divided by square root of 3 over 2. The 2's cross out, you would have negative 1 over root 3. So that occurs at 11 pi over 6. But that is not a valid answer. It's out of the range. So you go negative 30 or negative pi over 6. Okay, the most difficult part of these problems for most students a lot of times is not paying attention to the range. Your answer must fall within the range, so those things are very important to review and study. Okay, so that's how I would look at that type of problem. Now this next problem is another good thing because it tests several things on this. So let me show you. You're evaluating the cotangent of the inverse sine of 2/5, like this. And I did want to remind you also, before I go on to this problem, that you know, you want these exact answers. You're not going to get these exact answers on a calculator. But the thing that you can do on this is if you put your calculator in Radian mode, to me it's important to learn to use technology to check and verify everything. So if you did the inverse cosine of 1/2 in radians, well, you're going to get this answer. Well, our answer is pi over 3. So if we do pi divided by 3, well, we get the same thing, see. So all of these are verifiable. If you do the inverse sine of negative square root of 3 over 2, that gives this. Well, that's what negative pi over 3 is. Okay, so you can tell, we already did pi over 3, so you can tell that's right. Okay, and then finally, if you did the inverse tangent of negative 1 over the square root of 3, okay, you end up getting this answer. Well, let's see if that's negative pi over 6. So if I put in negative pi divided by 6, okay, then I've got, that verifies that answer, see. Okay, so you can easily go through and check and verify your answers to these problems. Okay. Okay, so moving down to this next problem, the first thing that you want to do is kind of figure out the quadrant you're in. So since you have an inverse sine, the range is negative pi over 2 to pi over 2. So since you have a negative number, you have sine of theta equals negative 2/5. That means you're in quadrant 4. Okay, so remember the sine is negative in quadrants 3 and 4, but because of the range, that forces you to be in quadrant 4. Okay, and what that tells you then is x is positive, y is negative, and of course r is always positive like that. So that's real important you figure out x, y, and r in this problem, which you can do pretty easily. but figuring that quadrant out is crucial. So the next thing is the sine, by definition, is y over r. So that would just mean in this particular problem, the second thing you consider is this is really saying sine theta is negative 2 over 5. So that tells you automatically what y is, and it tells you automatically what r is then. Okay, so basically y is negative 2, and r is going to be positive 5. Okay, and then of course we can go through and do Pythagorean Theorem to figure this out then. So we would end up just having x squared plus y squared equals r squared. So that's x squared plus 4 equals 25. That is x squared equals 21. Square root both sides, you're going to get x is plus minus root 21. But since we're in quadrant 4, we know that we have a positive answer like that. And then from here it's real easy. The third step is you're doing the cotangent of theta, which is x over y. So x is root 21, y is negative 2, so the answer of the problem would be square root of 21 over 2. Okay, like that. And that's it. Now, this problem is actually very easy to check on your calculator. It really is. So what you would want to do on there, it doesn't really matter what mode you're in on this, because it's all going to work out the same anyway. Actually, you could do this in one step, or you could do it in two steps. If you want to do this in one step, the cotangent is 1 over the tangent. And then you would just put in the inverse sine of negative root 21 over 2, like that. Oh, crap. Did I put something in here wrong? Oh, I put the wrong thing in. Gosh. Okay, no wonder. Okay, let's try again. 1 divided by tangent is the cotangent, and then we do the inverse sine of negative 2/5. Not the answer. Come on, teacher. Okay, there we go. All right, so we get this. Now, our answer was negative root 21 divided by 2. Oh, shoot. Okay, so let me pause and check and see if I did something wrong. Again, the teacher's getting senile or something. I don't know what the deal is. Look, I did 1 times tangent. Okay, let's try the last time, okay? The cotangent is 1 divided by tangent, and then we do inverse sine of negative 2/5. Okay, like that. All right, now let's see if that's the right answer. So now we go negative square root of 21 divided by 2, and let's see if we don't get the same thing. Hallelujah. Okay, all right. So yeah, you can check and tell you have the right answer on that with technology. Okay, but you couldn't get the correct answer of that with technology. Your graphing calculator isn't going to be kind enough to spit out a square root of 21 for you, see. So I'm wanting you to use calculators to check and verify stuff, okay? All right, so let's go to the last page here, okay? And let's see, on this, I want to go back and review a few formulas here. We're finding the area and the arc length, so we want to review this. I haven't done this in a long time, so the formula for an area of a sector is 1/2 r squared theta, and then theta must be in radians to get any kind of a sensible answer. So the first thing you'd want to do on this problem is change the 20 degrees to radians by multiplying by pi over 180. So you'd have 20 pi over 180, and that would reduce down to pi over, what is that, pi over 9, I guess, right? Okay. So the idea on that would be you have pi over 9 radians, and you can use a decimal on this if you want to. So anyway, all we do to do this is just this. 1/2 times the radius, which is 7 feet, squared, and then times pi over 9 like this. And you could do this in your calculator if you wanted to. So you could do 1/2 is 0.5, 7 squared is 49, and then you just have pi over 9. So you'd want to put that in your calculator to get the correct answer of the problem. So I've got 0.5 times 7 squared was 49 times, and then pi over 9. Okay, and then we'll round that off, and that'll give the area of the sector. So the area of the sector on that is going to be about 8.6. Again, we're doing area, so units are important to write that as 8.6 feet squared. Okay, like that. Okay. Okay, and the next thing we'll remind is the arc length. So we're trying to find S. So S is the length of this little piece of the circle called the arc. The formula for this that we learned is S equals R theta. And again, theta is in radians. Okay, so what we have is S equals the radius times the angle in radians, pi over 9. That gives 7 pi over 9, which is the exact answer. So I'll just do this to get a decimal answer. 7 pi over 9 is going to give about 2.4. That's not an area, that's just a dimension of length. So that's 2.4 feet like that. Okay, so that's how all the calculations would work on that. Okay, last problem. Okay, just kind of probably a law of sines, law of cosines type of thing possibly. Let's see kind of what we're getting into here. So we're finding the value of x in this. So let's see what we know. We know we have this side's 87. We have an angle 25 and an angle 40. Well, let's see. If we're going to find x, my thought would be eventually maybe we could use law of sines, because we'll have this side over this angle, and that angle is actually very easy to figure out. You just do 40 minus 25, so that angle right there is going to be 15 degrees. Okay, so that's a 15-degree angle. Now what we would have to do is we would have to somehow figure out, you know, these angles here, or we'd have to know those sides. So that might not be the way ultimately to do it. This may be just a good right triangle trig problem. Okay, like that. Well, the way I look at it is I could find two things. Okay, I could find this side right here easy enough just by a right triangle. So let's start with this right triangle right here, which has a side of 87 and an angle of 25. And I'll just call that h for the height. Well, that would be, if you do the sine, or, the tangent would be opposite over adjacent. So if we do the tangent of 25 degrees, we would have opposite h over 87. So therefore h would just be 87 times the tangent of 25. So that would end up giving this height right here. Okay, so I'll do that on the calculator. And again, check your mode. Got to go back to degree mode here. And when I do this, I've got 87 times tangent of, come on, 87 tangent of 25. I'll round that off to one decimal, so that height right there is about 40.6 feet. Okay, so we got that now. Okay, so I'll do that. Now the second thing I would do is, hey, we got this big triangle like this, and that big triangle has an angle of 40 degrees. It still has the same side of 87. Then I can call that y, and I can do the tangent. So if I do tangent of 40 degrees, that's y over 87. Y is equal to 87 tan 40. So I'm going to do that. Okay, like that, and that will give about 73 feet, like that. Okay, so what we just figured out is that whole big piece there is 73. So if we're going to find x, then all we got to do is subtract those two numbers, and we got it. So the third and last step, we'll just say is x is equal to the 73 minus the 40.6. So this turns out just to be right triangle trigonometry. You know, that's the simplest way that I can see to do this problem. Okay, and then that would wrap us up. Give us our final answer would be 32.4 feet. Okay, and that would wrap that up. Okay, so this is a really good review. I really picked, you know, just kind of representations of the big things you got to know. There's obviously a lot more that we learned, but these are the big things here. So these are the kind of things that I choose from. I don't give you a 21 problem final because you'd never finish it in the allotted time, but you want to go over and study these things. So study hard. Let me know if you need help, and hopefully this will help you to ace the final exam. Good luck.